Testing, testing, one, two, three. Testing, 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 testing. Okay.
There we go. Okay, that works. Testing, testing, testing. Okay.
Yeah, so after I joined Get Cracked, I got two offers, So
And how did Get Cracked help you?
it gave me a learning environment to, practice. So
Did you find the Discord community useful?
that's the number one benefit, honestly. I'm surrounded by high IQ people, so
guys, today we're going to do another interesting hopefully small project, and that is going to be an image viewer that we're coding from absolutely from scratch. And today is a day where I don't have any energy to code something super fancy, and I've been sitting here and preparing for this video to start this. And it's starting the first line of code. So let's go into the projects directory, and by the way, at the end of this video I want to have a simple image viewer that can open. It's going to be out of an image, and now here we need the first lines of code. That's the hard part. Let's call the project to be called iv.c. Let's include standard.io.h, and maybe, I don't even know if we need it, standard.lib.h, and then let's just churn out a small hello world. Printf hello world. And that's it. So once you have the hello world written, you've done 90%, well, maybe not 90%, wanted to mention this logical work. So you've done the first lines of code, projects, image viewer, and try to compile it. Also enable all the warnings and extra warnings, and debug the debug flag in case we need to debug. And let's see, and we get a hello world. Alright, awesome, the project is almost done. Okay, maybe the line that we need to continue with. So I want to open an image that has I want to open an image, so I need some window to open, right? Makes sense. So for that we're going to use a graphics library, and that is SDL2. I haven't set it up on this machine yet, so let's include it. And let's go to SDL2 documentation. In the installation, on the installation page, you can see how it's supposed to be set up. You can either build it from source, which I'm not going to do. I actually want to simplify the installation as much as possible. Wait, SDL2. Let's look up the installation for Ubuntu, and there's as the command. I'm not using Ubuntu, I'm using Linux Mint, by the way, but the commands should be the exact same. SDL2. Okay, so let's go here and paste that up. Install command. I hope this one is sufficient. Ah, damn it. And now it's doing something. Let's see. If we can get the library included and also a graphical user interface to open, then I'm completely satisfied for today. But okay, I can't finish the video that way. I have to finish it, the entire project. But I mean, psychologically, I'm happy. So the next step is to, now that we have installed the library, we should have the header files in the system. I think we can even check that if we list the files in user lib, maybe. Let's see, is there anything that's related to SDL? Not sure, but somewhere there should be something, right? lib64 maybe? No. Wait, let me go to user and then grab for SDL2. Or no, I need to find all files. Let's say all files, and I will grab the results that contain SDL2. It's under shared doc for probably for documentation, and the libraries are, well, okay, they are somewhere. I don't find them right now, but okay. So now that we have installed the library, the graphics library, the next thing that we're going to have to do is use it, and we can use it if we first we have to use those compilation flags here, SDL2 config --cf flags --libs. We can use those with our compilation command in GCC to include the library, to link the library. Oh, I need to sharpen my speech. So let's see what this command even does. SDL2 config cflags and libs, and as you can see, we get some options here as an output, and these options, if we specify this command, they are added to the compilation command. So let's now try to compile without these options, and it works. Damn, it works, because we don't use the library, I think. So let's make use of it. SDL2, and in SDL2 the first thing that we need to do is create a window. Well, the window is the actual thing that we're going to open graphically. And let me just copy all of this create window command here, and let me paste that. Okay, so we are creating a window. Let me call it p window. I'm prefixing a p to indicate that it's a pointer, but it's not necessary, obviously. Just looks fancy, as if I knew C. Really, because this is something you don't do in any other language, and makes you look as if you are a pro at C. So always prefix pointers with P. And now we have created a window, and maybe if we compile this now, then let's see if it works. It doesn't work, of course, because of course, I didn't even specify the arguments. Wait, I need to, as you can see, I need to specify the arguments title, X, Y, width, height, and flags. So let's give it a title, sample window. Oh no, let's give it a proper title, image viewer. Then X, Y, and X can be SDL window pause centered. That's because it is specified in the documentation here. The X position of the window, SDL window pause centered, or undefined. SDL window pause centered is a constant. It's probably just value -1 or something. And if the create window function encounters this constant, then it just positions the window at the center of the screen. As window pause centered should be somewhere, right? As window pause. No. Centered. There we go. Okay. Now, for the Y argument, we do exactly the same. Then for the width, let's use a width of 900 and a height of 600. Actually, later we need to adapt the width and height to the width and height of the image, obviously. But let's hard-code it for now. And then the flags are just going to be 0. The flags are, for everybody who's not familiar with them, they are either 0 or one or more SDL window flags ORed together, and the window flags are values such as those right here. For example, if you want the window to be full screen, or you want it to be borderless, or you want it to be minimized, maximized, whatever, mouse grab, then you can specify those flags here in the flags argument. We don't need any of that. I just want a simple window that opens, so I'm just going to specify 0. And let's compile. Of course it doesn't work because there's an undefined reference to SDL create window. And that means we have to link the library using the command that we found in the documentation right here. So let's copy that again. Let's recall our compilation command, jump to the end, and attach the SDL linking flags. And it compiled now. I think this is just a warning about an unused variable. So let's check. And as you can see, there's the program IV and source code iv.c, and let's start IV. And as you can see, there was a window for a fraction of a second, maybe even just a couple of milliseconds. Let me just recall it, pay attention now. And there was a very short burst of something, and that is because the application runs, opens a window and closes it right away when it finishes. So of course the process is done and then everything closes. So we can add an SDL delay here, and the delay is, let's say, 3 seconds, 3000 milliseconds. And now let's compile again. Unused variable, that's fine, and let's open the program, and there's our window. So we have a window that's opening at this.
When making a game, you use a game engine. But what if you wanted to do something more custom, like make a game from scratch? SDL. Is it a game engine? No. Is it a framework? No. It's a code library. You don't have to use it when making a game from scratch, but what do games do? Games need to draw to the screen, play audio, handle user input so you can interact with the game. All basic stuff you realize when playing a game, but the thing is, how Windows does those things is different than how Mac, or Linux, or PlayStation, or the Switch, and the Wii, and the Game Gear all handle those things. Remember Game Gear? That thing would eat 6 AA batteries and die in a 30-minute car ride. It couldn't even tenderize meat like the Game Boy.
Use them to tenderize meat.
But that is where SDL shines. You write the game code once using the tools SDL gives you, and under the hood it handles all of the platform-specific stuff for you, essentially making your game cross-platform. Now, if Sega used SDL, maybe the Game Gear could have tenderized meat like the Game Boy, and who knows how gaming history would have changed. You're still making your game from the ground floor, just using SDL is going to save you a lot of pain down the road. It's great. Or is it? See, I've never used SDL or made a game written in C, but that changes today. I'm going to do both and see if I can get a game set up and published for you to play and see for myself what it's really like to work with SDL, and it's great timing because SDL 3 just released. And to use it, it's as simple as just needing to install it. But turns out my distribution of Linux doesn't have a package of SDL 3 yet, so no problem, no big deal. We'll just have to build it from source. This is what real programmers do anyway. It definitely didn't take me 5 hours because I found the documentation very confusing. But check it out, we can now import an SDL3 library right off the rip in our file here. We're ready to go. At least we would be if I knew how to do anything, but I don't. Fortunately, there is good documentation on how to use SDL3, including these example projects. Like, check this one out. We can just copy and paste this code, and now we get this window that changes colors, and it's beautiful. And what's nice about these example projects is you can just pick apart the source code and see how things are set up. If you've only ever worked with a game engine like Unity or something before, working at a lower level like this, you might find interesting. Some of the SDL specific stuff is like creating a window. On its own, this window sucks. It doesn't do anything. You can drag it around maybe, but there's nothing there until you assign it a renderer. And a renderer is just like a canvas. You tell it to draw stuff, and it does, like textures. So we can give it this player texture to draw, and now your renderer that lives in a window is drawing your player texture. I mean, this is all very simple stuff. Nothing is revolutionary, right? But there are things you just take for granted that game engines do for you. For example, once we start moving this player texture around the screen, you'll notice that there's all these artifacts that get left behind. And to fix that, you have to explicitly tell the renderer to wipe itself clean at the end of every frame, and that way, when it draws the updated position of the player texture, it looks nice and smooth like this, which again, is no big deal. This is really easy stuff once you learn. play around with a lot of stuff. So I took this chance to change the background color to cornflower blue. Real ones know what I'm talking about. And while moving the player is great, I wanted to practice some collision too. So the easiest thing I figured out how to do is to do some bounds checking to make sure the player can't leave the window. And now you'll just run alongside it, no matter how hard you try to escape. You're trapped, you can't leave. And he never will. He'll never escape, which is perfect because now we can throw stuff at the player and they can't get away, like this very slow moving red box. Also, it somehow removed the cornflower blue color I just... See this clip? I'm restarting the game over and over, and you might notice that the block spawns in the same spot every single time. And if you've watched my channel before, you know that computers are just like plants in that they both have seeds, and we needed to update the seed here so that every time we run the game, it's a different randomly generated pattern, which is very important because now you actually have the makings of a game where you try and survive for as long as possible, and it gives you a score when you die. So at this point, as much as I love this player character and the red boxes, it's time to give the game a bit of a facelift, improve the art a little bit. So I added this new player sprite, and I made these slime guys to be the enemies or the red boxes, and then I also gave like a checkered pattern on. If you want to try it, don't be scared, go ahead and do it. Just don't make so many memory leaks like I did. You can find the game I made in this video, and you can play it in your browser, link in the description. If you want to see other games I've made or other ways to make games, make sure you subscribe, you're gonna miss it. And go ahead and watch this video because YouTube thinks you're gonna like it. Get out of here, go make games.
The center of our screen, and everything is working. It has an X 3.2 and it's increasing, and before it was just a couple hundred kilobytes. The second line is the comment. This right here is the maximum color value, which I would just ignore right now because for every reasonable modern file it's going to be 255. And let me cat the image ppm into it. So this is now the full syntax. Let me open the code again, just so we have every quit button in the top right corner. Then this variable is set to 0 and the app is not running anymore and the application quits. Alright, that's just a small detail that you have to consider when properly implementing graphical user interfaces. And now let's try to display the image. And it works. Awesome, guys. This is our own image viewer. It's working perfectly fine. And let's try to close the app.
Have you ever wondered how hard it is to actually learn coding? Or maybe you've seen a horrible batch of code and you've thought, who the hell wrote this? I want us to answer both of those questions by attempting to build a working chess game with zero coding experience. I'm not a computer science major. I'm not even in STEM. I just wanted to know if an average quick start guide on LinkedIn Learning. I also set one rule for myself during this challenge: no AI. So when I started working on rendering a chessboard, the reality of how difficult this was really going to be quickly set in. A quick Google search led me to a Python package called Turtle, which is a library that allows you to create shapes on a canvas and move them around with your code. Apparently, this is mostly used to teach kids about the basics of programming, so I thought it was well suited for my intelligence level. Using the Turtle package, I tried out a few different methods for rendering my chessboard with varying levels of success. I thought I had it solved at one point when I came up with a way to make a square trace the path of the chessboard and leave a stamp of itself for each square, all while alternating colors. But I ended up having to scrap that solution. Instead of stamping a shape, I needed to make a separate shape for each square on the board, pieces from occupying the same square. My solution? You got it. Another hard-coded dictionary. This one kept track of which pieces was on which square. Next, I made movement restrictions for the pawn that only allowed it to move 2 squares forward on move 1 and 1 square forward on any other move. Look at that, the pawn's working. Next up was the knight. The nice thing about the knight is that it can hop over pieces, meaning I didn't have to figure out if anything was blocking it. The knight essentially has 8 squares that it can move to, so I came up with an elegant solution. Using the coordinates from my notation dictionary, I wrote 8 if statements that check if the coordinates of the selected square match up with one of these 8 squares. Genius? I know. Then came the bishop. And this is the point in the project where the difficulty really started to step up. Solving the basic movement wasn't too bad. I just ended up comparing the distance traveled along the x coordinate and the distance traveled along the y coordinate. And if these two distances match, then the bishop is allowed to move there. But here's what was tricky about the bishop. The bishop is the first piece I've made that can't move through other pieces. I ended up using some very sophisticated mathematics to determine how far the bishop was traveling and what direction it was moving. Once I had that information, I was able to check all of the squares between the bishop and its destination square to determine if anything was blocking its path. Explaining it after the fact might make it sound simple, but as someone who has never coded in his life, this felt like a huge accomplishment to figure out. The rook and the queen were actually very similar to the bishop. The rook followed the exact same concept, just horizontal and vertical. And the queen, get this, I had a beautiful thought. What if the queen is just bishop plus rook? And yes, it was. I literally just copied the rook logic, pasted it directly after the bishop logic, and wrapped that all in a nice little if piece equals queen, and boom, the queen was working perfectly. The king was also really easy, at least at first. I just created some conditional logic that allowed the king to move to any immediate surrounding square that wasn't occupied. Little did I know that the special rules for the king would later prove to be the most challenging aspect. No, but did it work? Also no. At least not at first. However, after addressing a couple of bugs, the board flips were working. At this point, I had to build out a system that keeps track of which team is taking their turn to prevent the black. Look at this. This game is really starting to look like chess. I felt so close, but I would soon realize that I was still so far. If you aren't aware, chess has a few special rules that allow pieces to do things they normally cannot. The first is called castling. If both the king and the rook haven't moved, the player can make them do a little flip-flop. If a pawn moves 2 squares forward on its first move, and an enemy a square behind it as en passant eligible, logic that decides if that move is valid. That works fine until you introduce the king, because now it's not enough to just
This is Chinese PhD student Zhuming Li using a syringe to inject chemicals into his neighbor's apartment to retaliate against the sound of their crying baby. For months, the family living inside this unit had been suffering from unexplained illnesses until they hit a small camera inside a potted plant and caught his downstairs neighbor doing this. Fearing for his family's lives, the husband immediately called the police. As officers and hazmat units started swarming the building, this Chinese immigrant would quickly realize the huge trouble he was in.
Hello. What's going on?
He's a chemistry PhD student yourself.
He's a what?
Chemistry PhD student at yourself.
Okay.
And he's injecting some chemical inside my house. It's like severe eye burning sensation. Eyes are
Let me see the video.
difficulty breathing.
Do you know him?
Yeah.
Are you guys in an argument about something?
I'll tell you everything. So this time he came and he didn't put anything. But he came back again and this is breath.
Here, come downstairs. Let the fire guys check you out. Okay?
when my baby wakes up in the middle of the night, he complains. We are doing heavy footsteps. He's hearing all the sound and he's waking up.
Did you guys call a long time ago? Or for some noise? He called.
He called.
And we talked to you.
Yes.
So, this is an odd call. He does have a video of his downstairs neighbor with a syringe squirting something into his door that's closed, his front door. So he said he kind of had some, you said your eyes were burning?
Yes.
So I haven't been in the apartment yet.
Have a seat out here in the air.
And the baby and his wife went to another apartment to kind of get away.
This dispute didn't begin that day, but months earlier, when the suspect, Zuming Li, a Chinese PhD chemistry student at the University of South Florida on a student visa, called police to complain about noise